Okay, so in this unit, this is a new unit, we're going to start rational expressions. And rational expressions we kind of talked about before is just a fraction. And so these are just fractions that are made up of polynomials. And so we're going to simplify those just like we would regular fractions. I really love this unit because I love rational expressions. I think these are fun. So before we start out, first step that we're going to go through for solving any of these is we always need to factor the numerator and then factor the denominator if we can. Sometimes we can't. And then we'll be able to cancel common terms. Now, before we go ahead and start simplifying here, I want to talk to you about when you can and when you cannot cancel things out. So let's just add a page. So let's look at a fraction. Let's say I had 3 times 4 divided by 3 times 5. There's one of two ways that I could simplify this. The first way would be to go ahead and take my problem, 3 times 4 divided by 3 times 5, and say, okay, well, I can go ahead and cancel those 3's out because 3 divided by 3 would be 1, and it would leave me with 4/5. So I could do that. The second way that I could do it would be to multiply this. So 3 times 4 would be 12, 3 times 5 is 15, and then I could reduce that fraction to get 4/5. And these two things give me the same thing. So it works. Now, this is when we can cancel things out. The reason that I could cancel the 3's right here is because in between the 3 and the 4 and the 3 and the 5 was multiplication. Let's look at saying if we have 3 plus 4 divided by 3 plus 5. Now, this one I cannot do two ways. I cannot go up here and take my problem, 3 plus 4 over 3 plus 5, and say that I can cancel these 3's out. And then my problem would just give me 4 over 5. I cannot do that. This will not work. If it's attached to a plus here, that won't work. We know that if we actually do this problem, 3 plus 4 would give me 7, and 3 plus 5 would give me 8. So this does not give me the right answer. So if we have things that are being added, we cannot, or subtracted, we cannot cancel. And so with this kind of problem right here, a lot of people will try to go ahead and say, all right, I'll cancel this x to the third with that x squared, and that'll leave me with 1x there. Okay, you cannot do that. That's why it's really important to do the steps that we put out here and factor whenever you can. So we've got to factor this. In the top, the first thing I'm going to do is factor out a GCF. So I'm going to factor out an x, and that'll leave me with x squared minus 4. If I factor the bottom, I'm just going to backwards FOIL or factor that out into 2 parentheses. This is going to be x and x, 2 and 1, and then it'll have to be plus. And then it'll have to be plus and minus. And so then I'm not quite done factoring yet because this special case right here, x is squared and 4 is also what's called a perfect square. Meaning 2 times 2 would give me 4. So I can multiply 2 by itself and get 4. So if you have this case, this is the case where when you factor it, you'll end up having x and x, 2 and 2. One will be plus and one will be minus. And the one that's plus and minus, the outside and inside terms, if we were to FOIL that back out, those terms would cancel out. And so we have to have one factor that has plus, one factor that has minus. So this is a difference of 2 squares, so I call that dots. So we had dots right there, we factored it out. I'm going to leave the bottom the same, and then I can go ahead and cancel because now there's multiplication in between all of those factors, and so I can cancel. So that will end up canceling out, and I'll be left with x times x minus 2 over x minus 1. Alright, number 2. I'm going to do the exact same thing with number 2 as I did with number 1, except before I can factor or backwards FOIL the top of this one, I need to turn it around. And I would like for you to always show this step because a lot of people will try to do it in their heads and it messes them up. So I would show where I turn it around, negative x squared plus x plus 12. And then I would also show where I factor out this negative. And I'm going to factor the negative out right above it. And then that helps me see how that polynomial will backwards FOIL. So I'm going to go ahead and do that and come over here. I'm just going to factor the bottom in this last fraction. So when I factor the bottom, that's going to be 2x and x. It'll end up having to be 4 and 1, and both of these signs will need to be minus. Now in the top, I'm going to have a minus, and then I'm going to backwards FOIL, so this is going to be x and x. It'll have to be 4 and 3, and I'll have minus 4 plus 3. And so now I can go ahead and cancel. You have to make sure that you don't forget this negative that's out there that you factored out. So x minus 4's will cancel, and my final answer will be negative x plus 3 over 2x minus 1. Alright, number 3. This one has in the bottom the special case we just talked about. That's dots, difference of two squares. A is squared and so is b. So I know how that will factor. This will just factor into a plus b and a minus b. Now the top is a special case called a sum and difference, or sum or difference of cubes. This we have a difference of cubes. And so you should have learned this in Algebra 2, but in case you didn't, let's just review the formulas to factor this. So whenever you have sum and differences of cubes, I'll move that up there, then this is the formula that you're going to use to factor. And the way that you always factor a sum or difference of cubes is it's going to factor into a trinomial or a binomial and a trinomial, a term or a factor with 2 terms and a factor with 3 terms. Now the way that you get these things, the terms inside the factors, is the same. So in order to get this binomial right here, we're always going to take the cube root of whatever we have here. So the cube root of x cubed is just x. Same thing for the y. The cube root of y cubed is just y. And so once you get this, these terms you can find by using your first factor. So I would take x and square it to get the first term. And then to get the middle term, I'm just going to multiply x and y, or whatever these two terms are. And then for the last term, I'm just going to take y and square it. Now, the way that you remember how the signs are going to go is you take your original sign. And so the sign in the factored form is always going to be SOAP. So the first sign will stay the same, the second sign will be opposite, and then the last will always be positive. So you can see that our original here was a plus, and so this is the same, which is plus, opposite, which is minus, and then always positive. And then if we have a difference, which is what we have, the first sign will be the same, which is minus, second sign is opposite, which is plus, and the last sign is always positive. So these are the formulas for sum and difference of cubes, and that's what we're going to use in the top. So I'm going to erase this. And so let's go ahead and factor the top now. I know it's going to factor into a trinomial and a binomial. So I'm going to get my first term by taking the cube root of a cubed, which is just a. My second term by taking the cube root of b cubed, which is just b. And then to get the trinomial, I'm going to take a and square it. The middle term is going to be a times b, which is just ab. And then the last term is just b squared. And so then the signs are SOAP. So same, opposite, always positive. Now I can cancel this, and I'm left with this a squared plus ab plus b squared. Now, this is my final answer because whenever you do SOAP, this trinomial will never factor again, ever, in any SOAP. So once this is, if you've SOAP, then this you shouldn't even try to factor anymore because it's not gonna work. So I'm gonna leave that, and that's my final answer. Okay, number 4, I want you guys to try this one on your own. So I would pause and then try this again. I'm gonna go ahead and work it out. This is gonna be y and y. This would be 4 and 3. Both have to be minus. This one's an easier one. Y and y. This would have to be 6 and 3. And this would end up being a plus 6 minus 3. So my y minus 3's will cancel. And so my final answer will be y minus 4 over y plus 6. Alright, number 5. I'm going to have to do the same thing with the top of this as I did a problem that was a couple of problems ago. So I need to turn it around and factor out a negative. I'm going to show that step. So this is negative x cubed plus 2x squared minus x plus 2. And then before I write my denominator, I'm going to go ahead and factor that negative out. So this is going to be x cubed minus 2x squared plus x minus 2. Now, anytime you have 4 terms, you should remember we went over this in our last unit, that this is going to require grouping to factor. And so I'm going to end up having to group these terms. So I'm going to group the first two and group the second two. I'm going to remember my minus. And so inside here, I'm going to factor out an x squared first. And when I do that, it'll leave me with x minus 2. Plus, there's nothing really to factor out of that last group, so I can kind of factor out a 1, because if I do, it won't really change anything. And so this is going to end up giving me x minus 2. It doesn't change it. And so now when I factor, I've got two terms. I've got this term and I've got this term. And remember, those two terms have in common that x minus 2 now. So it's kind of like we're factoring out another GCF. So I'm going to go ahead and I'm going to come over here and write this. This is going to be negative. And then I'll factor out my x minus 2. And then from the first term, I'm going to be left with an x squared. From the second term, I'll be left with a plus 1. And so there's my factored form. And I'm going to go ahead and erase these extra parentheses and just stick my negative out front. And then that's all over x minus 2. And so now I can cancel. And then my final answer should be a negative x squared plus 1. Now I'm going to leave it like this. Don't try to factor this anymore, because this, even though it looks like it could be a difference of two cubes, or not cubes, but squares, we can't factor this into like x plus 1 and x plus 1 because the middle terms wouldn't cancel out. So this is a sum of two squares, not a difference of two squares. So this isn't dots, so we can't factor that. So that's going to be my final answer. Alright, last problem. I would pause it and try here too if you want to. I'm going to go ahead and work it out. So the top of this is going to stay x minus 9. So I'm just going to leave this x minus 9, and I'm going to come down here and go ahead and do my grouping. Now, if I have a minus in the center, I'm going to group that minus in because I need to factor it out as a GCF. So I'm going to factor out x squared. This will leave me with x plus 1. I factor out a negative 9, and it'll leave me with x plus 1. So then, here's my first term, here's my second term. They have in common the x plus 1. So when I factor that out, it'll leave me with x squared minus 9. Now, once I do that, I can see that I'm still left with a set of dots. So I can factor that one more time since it's a difference of two squares. So this is going to be x plus 1 in the top. And then I'm going to go ahead and factor the x squared minus 9. That's going to end up being x plus 3 and x minus 3. Sometimes you may not have to cancel anything out, or you may not be able to. So this one is one of those where we can't cancel anything out after we factor, and so there's my final answer. And the reason that we would leave it in this form or want to factor it out is because later in this unit we're going to get to asymptotes. And so if it's in this format with all the factors in the bottom, it's much easier to find vertical asymptotes of this function.